Hi everyone, Tina here, and today I'd like to talk about compound growth and decay. This is when you have percentage change happening year on year or month on month, and you have to work out the combined effect of that percentage change over however many years or months. You'll need to know about this topic for both the Foundation and Higher GCSE maths courses. Here is the formula that we're going to use, but it will make more sense when we look at some examples. So the formula says that the new amount is equal to the original amount times something called a multiplier to the power of n. N is the number of years or months or weeks or days, whatever it's going to talk about in the question. And the multiplier depends on the percentage change and whether the amount is increasing or decreasing. I'll show you how you work with this in some examples now. Example 1. Leanne invests £2,500 for 4 years in a savings account. She gets 3% per annum compound interest. How much money does Leanne have at the end of the 4 years? So first of all, per annum just means per year. Then I have the formula here, so new amount equals original amount times the multiplier to the power of n. In this case, the multiplier is going to be the 100% that you start with plus the 3% per annum or per year, giving a multiplier of 103%. It's a percentage increase because she's investing this money into a savings account, so the compound interest will be added onto her money. So we add the 3% onto the 100%. 103% as a decimal is 1.03, and that's the value that we're going to use inside that bracket. So overall, the new amount is going to be equal to the £2,500 she invested times 1.03 to the power of 4 in this case, because she had it in the account for 4 years. If you type that into the calculator, you get 2,813.77. So for money, it's always a good idea to round the answer to 2 decimal places to take into account the pennies. Example 2. Perry invests £25,000 for 3 years in a savings account. She gets 2.7% per annum compound interest. Calculate the total amount of interest Perry will get after 3 years. Now in this question, we're dealing with a savings account and compound interest again. So the multiplier is going to be similar to the one we had before. We're going to start with our 100% original investment, and this time add on 2.7%. That is 102.7%, which is 1.027 as a decimal. Then we can go ahead and substitute that into the formula. So the new amount is going to be her 25,000 times 1.027 to the power of 3 in this case, because we're doing it for 3 years. In the calculator, that gives £27,080.17. But in this question, they only want to know the total amount of interest Perry will get. So we'll need to take that new amount of money and subtract her original investment, and that is £2,080.17. So that's the interest that she gets on top of her investment. Example 3. Hamish buys a new car for $20,000. The car depreciates in value by 19% each year. Work out the value of the car at the end of the 3 years. Give your answer to the nearest dollar. This time it's a bit different because the car is depreciating in value, meaning we're going to have a percentage decrease in value. The multiplier will still start with 100% as the original price of the car, but this time we're going to subtract the 19%. This is 81%, which as a decimal is 0.81. Now we can just use the formula as normal. So new amount equals the original amount, which was $20,000, times 0.81 to the power of 3 for the 3 years. Typing this into the calculator gives $10,628.82. So to the nearest dollar, we are going to put $10,629. Example 4. Nick bought a new car. Each year the car depreciates in value by 12%. Work out the number of years it takes for the car to halve in value. So we have a car again, which is depreciating in value, so percentage decrease. But this time they want to know the number of years it takes for the car to halve in value. So it's actually that n value that we're going to want to find. We can still use the formula, but we're going to need to use trial and error to find n. To make this easier, we can come up with an original cost of the car. You can choose whatever value you like, but I'm going to say that originally, let the car cost £10,000. and this can be the original value. Then the question we're really asking is how many years until the new value is £5,000? Because 5,000 is half of the original value of 10,000. Now we need to use the formula again, so we need to work out our multiplier. This time we're going to start with 100% and decrease by 12% because it's depreciating in value, and that is 88% or 0.88. And then we can use the formula. So with our values, we're going to try 10,000 times 0.88 to the power of, let's say, 4 first, just to see what that gives us. So if we type that in, we get 5,996.95. So it's still not quite the 5,000 yet. So let's try adding on another year. 10,000 times 0.88 to the power of 5. After 5 years, the car's value is 5,277.32. So getting closer, but still not 5,000. Trying one more year on top gives 4,644.04. So 6 years is the answer, because after 6 years, the value of the car has gone down from £10,000 to less than the £5,000. Example 5, Lucy invests some money into a savings account which pays 4% compound interest per year. After 5 years, she has £18,249.79 in that account. How much money did she originally invest? So for this one, we can still use our formula, but we're trying to find the original amount this time, rather than the new amount. So let's sort out the multiplier. In this case, it's a savings account with compound interest, so percentage increase. 100% plus 4% gives 104%, or 1.04. And then we can use the formula, but just be careful to put the numbers in the right place. So for example here, the new amount we actually know this time is 18,249.79. The original amount is what we want, so I'm going to label that as X, as an unknown, times 1.04 to the power of 5, because we do know that she invested the money for 5 years. Now it's just a case of rearranging this formula to make X the subject. So in this case, we want to divide both sides by 1.04 to the power of 5. So that will leave X on this side, and then 18,249.79 over 1.04 to the power of 5. This you can just type into the calculator and you end up with 14,999.997. If we round this, we get £15,000, and that was her original investment. Last example, Jan invests $8,000 in a savings account. The account pays compound interest at a rate of X% per year. At the end of 6 years, there is a total of 8,877.62 in the account. Work out the value of X. Give your answer correct at 2 decimal places. So this is the hardest example that we've seen, because in this case, we actually don't know the compound interest rate. So we don't know what the multiplier is going to be yet. That's okay, we can still use the formula. So in this case, we know that the new amount that Jan has is 8,877.62. We know her original amount was 8,000. We don't know the multiplier, so I'm going to use the letter Y to represent that unknown. I would normally use X, but X% is given in the question, so I don't want to get them confused. And then we do know N is 6. So this is the formula that we're working with, and we want to rearrange this to find out Y. To do this, we can divide both sides by 8,000 first. And if you type that into your calculator, you get 1.109725. Now to get Y on its own, we can undo that power of 6 by saying that Y is equal to the 6th root of 1.109725. In the calculator, that gives 1.0175. This time, we want to turn the decimal back into a percentage. So this time, if we multiply by 100, we're going to get 101.75%. So that compound interest rate must be 1.75%. X equals 1.75%, because it's 1.75% above the 100% original value. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else that you think might find it helpful. Thanks, and see you next time.